Okay, good afternoon everyone. So I'll continue from the previous video where I was finalizing with talking about relations, Cartesian products, and the different types of relations. So in this video, I want to focus mainly on what we call graphs, and these graphs will also use some knowledge from relations. So now you know what a relation is, so you are building on a relation to define what a graph is. So in this case, I don't want you to think about a graph as like what you know, that you draw an x-axis, y-axis, and then you do those vertical bars. In this case, we are not talking about the histogram or the bar graph and so on, but we are looking at a graph as an ordered pair. Simple as that. That's the definition of the graph we are interested in. So, which ordered pair is this? Is an ordered pair. So you can see that this ordered pair consists of two items. We have capital V, we have capital E. What is capital V? What is capital E? Capital V is the set of vertices, yeah, while capital E is the set of edges. So a vertex can be any point. You can circle it, or you can make a circle which is very bold, and then if you draw another point and then you connect those 2 points using a line. So those 2 points which you've connected using a line are what we call the vertices, and that line connecting those 2 points is what we call an edge. So for a graph, you have a set of vertices and a set of edges. So those two sets, when you put them together, then you form what we are calling a graph. So when they ask you to define a graph, you just say it's an ordered pair, VE, and then you tell us what V is and tell us what capital E is. And under graphs, there are some different definitions or terminology that we shall be coming across. And the first such terminology is what you call an directed graph. So this is not complicated. I want you to first look at this. Direct. It comes from the word direction. So if something is undirected, that means it doesn't pay importance to direction. And for example, when you're walking on the road, there are road signs. And what do road signs use to show you that, okay, this is the direction that you should take? They always use arrows, right? So a directed graph has different points connected with edges, but there are no arrows on those graphs. So we call those graphs undirected graphs. For example, when you look at this graph here, we have different points. We have a point A, point B, point C, point D. These are now the vertices. And these points have been connected with edges. So there is an edge from A to B, an edge from B to D, an edge from B to C. So these are the different edges. So we shall say that this whole diagram of figure 1a is a graph VE, where V, then you list all the vertices, which are A, B, C, D, and E is the set of edges AB, BC, and BD. So these are the vertices and these are the edges that we have in this graph. So you can see that we don't have an edge, a D, because points of vertices A and D are not connected by an edge in this case. Okay, so that is what a directed graph is. We don't have arrows. And the opposite of a directed graph, or the opposite of undirected graph would be a directed graph. So if undirected graph has no arrows, then it means that its opposite, which is the directed graph, will have arrows. So for a directed graph, you'll be able to know that the edge is moving from A to B if the arrow is pointing towards B, or an edge is moving from B to A if the arrow is pointing towards A. I hope you understand what I'm trying to say. Okay, so you have another example of a graph here. We have how many vertices? We have V1, V2, V3, V4, V5, and V6. So this is the set of vertices, and the set of edges are V1 to V2, that is one edge, V1 to V3, that's another edge, V1 to V4, that's another edge, V1 to V5. Do we have a direct edge here? I think this should not be part. Oh, V1, no, it is V4 to V5, yes. V4 to V5, we have an edge, yes. And V5 to V6, we have an edge. So you can see that we are writing these edges as ordered pairs, which are relations. So that's why we define a graph as a relation. But also in other cases, the edges can be labeled. For example, they can call this one E1, E2, E3, E4, E5, and so on. So if they are labeled, well and good. But in case they are not labeled, then we shall use their vertices to define them, as you can see here. V1, V2 to mean an edge moving from vertex V1 to vertex V2. Okay. Let's move to another terminology, which is the cardinality of a graph. Cardinality of a graph, which you also sometimes denote as this. I think this notation is not new from sets. We saw if you're finding cardinality of a set, you can write it this way. But how about cardinality of a graph? So cardinality of a graph is the number of vertices in the graph. For example, if you want to find the cardinality of this first graph here, just count how many vertices it has. So this has 1, 2, 3, 4. So it has 4 vertices. So the cardinality of this graph is 4. While the cardinality of this second graph is, how many vertices do we have? There, 1, 2, 3, 4, 5, 6. So the cardinality of this graph is 6. Okay. So then there's an example here for you to try that. Are the following pairs connected by a line? So they want you to look at the graphs look at the graph here and then tell whether there is an edge between V1 and V6, V1 and V3, and so on. So in this exercise, remember, we've already looked at all these vertices here. So we have V1, V2, V1, V3, V1, V4, V1, V5, V5, V6. So in this exercise, what you're required to do is just tick. For example, you have V1, V2, V1, V2, there is an edge, so you can put a tick here. V1, V1, there is no edge between V1 and V1, so you put a cross. V2, V3, there is an edge, you put a tick here. V2, V4, is there an edge? Let's look at the graph. V2, V4, V2, V4, there is no edge, so you put a cross. Okay, so for V2, V4, we are putting a cross. So you do the same for the entire table and you see what you come up with. That's just a simple exercise for you to try out. let's look at a different terminology, that is the degree of a vertex. What is the degree of a vertex? We know now what a vertex is. So given a graph and looking at a vertex, how will you tell its degree? So you are saying that degree of a vertex is the number of edges coming from that vertex. So just look at a vertex and count the edges which connect to it. Okay? So then they are giving an example that the degree of V1 is 3. So let's count the edges connecting to V1. V1 is here. Okay? How many edges are connecting to V1? There is this edge, there is this edge, those are 2. There is this edge, those are 3. So the degree of V1 is 3. The degree of V2, there's only one edge connecting to V2. So the degree of V2 is 1. How about the degree of V4? There is this edge here from V1, and there's also the second edge connecting to V5. So V4 has degree 2, and so on. So as simple as that. And this will be true for undirected graph. Otherwise, when it comes to a directed graph, then you will see the different terminology that we shall use. Okay. Then there is another important concept here, that a loop contributes degree 2. So in this case, a loop is an edge from a vertex back to that vertex. For example, you can have an edge from V1 to V1. Okay, that will be the loop. Let me see if I can demonstrate on this graph here. Okay, what is a pencil? Maybe this one. We will draw. So suppose you want a loop from V1 to V1. Okay, let me use V4. Then we shall draw something like this. Yeah. So this will be the loop. It's an edge. It comes from V4 and goes back to V4. If we had it on V5, we would have something like this. V5. Oh, it's not drawing. Let me choose color red. Okay. Will it draw this time? Oh my god, it's not drawing. Let me select again. It's not drawing, but I've showed you what a loop is. It's an edge. It comes from a vertex and goes back to the same vertex. Okay. And we are saying that a loop contributes a degree of 2 to its terminal vertex, excluding the contribution from others. So that means in this example, V4, we already said it had degree 2, but because of this loop, which contributes a degree of 2, that means the loop alone will contribute degree 2, then plus this edge, that is 3, plus this edge, that is 4. So the degree of V4, if we had a loop, would be 4. Okay? Okay, let's move to the next one. Adjacent vertices. When do we say that two vertices in a graph are adjacent? So we say that two vertices in a graph are adjacent if they are connected by an edge. And that can be said this way, that two vertices are adjacent if they are terminal vertices for the same edge. Like you have an edge, and then at the ends of that edge, there is a vertex. There is also another vertex at the other end. For example, from this we are saying that V1 and V2, V1, V3, V1, V4 are terminal vertices. Okay, because you have an edge connecting V1 to V2, V1 to V3, V1 to V4. Let's see from the graph. Yeah, you have an edge connecting from V1 to V2. So V1 and V2 are terminal vertices for that edge V1, V2. So the simple trick is for you to identify adjacent vertices. You just look at an edge and then find out the vertices which that edge connects. Those will be the terminal vertices. Okay? Yeah. So you should be able to also confirm that V6 and V5 are also terminal vertices because there is an edge connecting them. V5 and V4 are terminal vertices. Let me see from the graph. I don't remember this. V5 and oh my god, yes, they are V4 and V5. There is an edge connecting them. So they are terminal vertices for that edge. Okay. So you go through the rest and find out. So computer scientists or programmers, they can always come up with programs that given a graph with some vertices and edges, can they be able to find the list of vertices which are adjacent. So that's what this table is all about, but I'm not very much interested in the computer programs at the moment, so you can just ignore this table. Okay. Okay, then another term, terminal vertices. So terminal vertices and adjacent vertices are the same thing almost, because we can determine them given an edge. So that's why you're saying that if you have an edge EIJ, meaning an edge coming from vertex VI to vertex J, okay, then VI and VJ are terminal vertices. So terminal vertices or adjacent vertices mean the same thing. For example, an edge E43, it means vertex 4 and vertex 3 are terminal vertices, or another person can say that they are adjacent vertices because they are connected by the same edge. And this edge which connects terminal vertices or adjacent vertices, we call it an incident edge. For example, this was supposed to be E23. Edge E23 from this graph, edge E23 is an incident edge on vertex 2 and vertex 3 because it connects the two. So an edge which connects two vertices, we call it an incident edge on the vertices. And for a loop, we already looked at the definition of a loop. We saw that a loop is an edge which comes from vertex and goes back to the same vertex. For example, E33 is a loop on vertex 3. Let's see vertex 3. Yeah, so vertex 3 is here. We have an edge which comes from vertex 3 and goes back to vertex 3. So that will be a loop. Okay. Isolated vertex, just like the name isolated. If someone is isolated, that means they don't have friends, they're not connected to anyone. So the same applies to graphs. An isolated vertex is a vertex which is not connected to any other vertices, meaning there is no edge connecting that vertex to others. Let's see if we have one vertex of that. Yeah, we have it here, V6. V6 is not connected to any vertex here, so there is no edge connecting it to any vertex in this graph. So we say that V6 is isolated. Okay. Then parallel edges. Parallel edges, what does it mean? We are saying that if there are more than one edge between the same pair of terminal vertices, then they are known as parallel edges. For example, E prime 24 and E24 are parallel edges. Let's see from this graph. Okay, so this straight one is the E24, and this other one, you should correct this, is the E prime 24. So let's look at E24. E24 connects vertex 2 and vertex 4. Okay. How about E prime 24? E prime 24 also comes from vertex 2 and connects to vertex 4. So these two edges are connecting the same pair of vertices. So if you have such edges in a graph, then we call those two edges parallel edges. Okay? Yeah. Then another concept is simple and multi graphs. What is a simple graph? What is a multi graph? So you're saying that a simple graph contains no loops. You know what a loop is. So in a simple graph, you don't have any loop. And another condition is that in a simple graph, you don't have any parallel edges. For example, here, we don't have any loop and we don't have any parallel edges. While a multi-graph contains loops, or it can contain parallel edges, or it can contain both. So as you can see here, we don't have loops, but we have parallel edges. There is this edge here. Suppose this is vertex A and this is vertex B. We have this vertical edge and there's also this other edge, meaning that this graph has parallel edges, so we call it a multi-graph. So you should be able to tell the difference between the two kinds of graphs. Okay. How about a pending vertex? A pending vertex has degree 1. If you have a graph, look at the edges connecting the vertices. Any vertex which has just one edge connecting to it, we call it a pending vertex. For example, in this graph, you can see that vertex V1 has only one edge connecting to it. Vertex V2 also has just one edge connecting to it. So the degree of vertex 1 is equal to the degree of vertex 2, and that degree is 1. So V1 and V2 are pending vertices for this graph. And a weighted graph, this comes from the word weight. You have a graph and then you can decide to add some values, associate a value. That value can be like say length, it can be like height. So if you have a graph and then you attach a value either on a vertex or on the edge, then you call it a weighted graph. For example, here we have vertices A, B, C, and along the edges we have put some values here. Those values can be, say, the length. Someone can look at this 10 and say that, okay, 10 could be the distance from A to B. 20 could be the distance from A to C. So if you have a graph and you've associated some values along either the vertices or the edges, then we call it a weighted graph. So I'll pause this video at this point. The next video we shall start by looking at a tree. Okay, I hope you enjoy it. Thank you for watching.